So representation of discrete time signal is classified into graphical representation, functional representation, tabular representation, sequential representation. For continuous time signal, we can represent as x of t, and the discrete time signal the represent as y x of n. So first one is graphical representation. So graphical representation, let us consider this is x n of values. These are the values x of n is equal to x of minus 2 and zero point 0.5, and x of minus 1 is 1.5, and x of 0 and x of 1 2.5. So this is the value they given. So how will be representing graphical? So if it is that n is nothing but its time period, that is 0. So if it is 0, that is 2 value, then minus 1 minus 2, then after right side of the 0 they put it as 1 2 3 4 5. So where is the 1 n value? 2.5, that is here, and another one is 2, that is zero point 0.5 here, and 3 and 1.5, and 4 5 is not there, that's why they put it as 0, that means nothing done over here. And functional representation, it's the same value they take it as, but the only thing is x of n is equal to the function of the values written here. Then for n value they put it as minus zero point 0.2 and 2, the both minus 2, and what about another value? The 2 is there, the zero point 0.5 value here, also zero point 0.5 value, and another zero point 0.5 value here. So minus 2 is also zero point 0.5 value, x of 2 also zero point 0.5 value. That's why they put it as n is equal to minus 2 comma 2. Then 1.5 n is equal to minus 1 3. So where about 1.5 here, then here also 1.5 there. So x of minus 1 and x of 3 is 1.3. Then 2 n is equal to 0, 2.5 n is equal to 1. Otherwise, this is a functional representation. And tabular representation x of n, so this is a value, same value take it, but only the different is tabular table we done over here, and n value then x of n value. So what is n value? So inside the bracket is n value, and x of n value is out of the uh, final output values. And sequence representation means this is the sequence representation. X of n is equal to double bracket is there. So 0.5, 1.5, 2, 2.5, 0.5, everything is there. So this is minus 1, this will be represented as minus 2, and this is plus 1, 2, 3, like that. The center place is origin, that is we put it as arrow, that is x of 0. So this is sequence representation. So this sequence representation present in all the places. Even coming problems, digital signal processor, they always use to this sequence representation, because it is compared to other representation, it little bit easy to understand. Also, it is easy to write. Next one, elementary of continuous time signal. So unit step signal is there. So unit step signal means, so v of t is equal to 1. So for t 0 is greater than or equal to 0, that is 1. So t is less than or equal to 0 means 0. So this unit step signal. So it's a graphical representation for unit step signal. So 0 1.0, the put it there is right side continuous time signal, like that, because it is 0 and more than 0, the value is 1. If it is less than 0, the value is 0. That is called as unit step signal. The graphical representation of unit step signal, this is like that. And unit ramp signal, so r of t is equal to t for 0 and more than 0 value is t, 0 and more than value is t, so less than value is 0. So this is a graphical representation of ramp signal. So for t value is started from here. So the value is started 1 unit ramp signal. So even x and y both the same value. It's a ramp, so like linear values. And 2 2. So this is t. So r of t is equal to t. So t is nothing but more than 0. So ramp function, it look like a ramp signal. And unit impulse function means del of t. So del of t is always is equal to 1. So del of t is equal to 0. When it is will be 0, even t is not equal to 0. So when t is equal to not equal to 0, del of value is 0. That means it's t have, when t is 0, then the value is 1. So this is a unit impulse function. So unit impulse function is nothing but del of t. Del of t is equal to 1. So this is for impulse function. So 0 and del of t. when t is equal to 0. When t is not equal to 0, then del of t is equal to 1. So minus infinity to plus infinity, del of t dt is equal to 1. And sinusoidal signal, so continuous time sinusoidal signal is given by, so x of t, a sine omega t plus theta. So graphical representation for sinusoidal signal. So this is sinusoidal signal. And real exponential signals, so defined as x of t is equal to e power a t. So graphical representation, so a, so this is a real exponential signal, so graphical representation. So this one is a growing signal, this one is a decaying signal, and this one is a constant value. A is if it is constant. So this is a formula, a power a n x of t is equal to e power a n. So this is a less than 1, then it's a growing. So real exponential if more than 1. So if it is more than 1, it is growing. If it is less than 1a, then it is decaying. For a is 0, it is constant for graphical representation. And elementary signal for discrete time signals. So previously we seen continuous time signal. This one is for discrete time signal. So e of n is equal to 1 0. So 0 and more than that, you will be get it like that graphical representation. Unit ramp signals. So r of n is n for So previously we seen the t, here is n. Okay, the graphical representation of unit ramp signal is going like that. And unit sample signal, so it's a sample del of n 1 is equal to 0. So graphical representation in impulse signals. And sinusoidal signals for the graphical representation, this is the value. And exponential signal, if it is less than 1, it's decaying. If it is greater than 1, that a value, it is growing. Okay, so this is the value of like that for exponential signal. So x of n is equal to a power n for all n. Okay, then operation on signals. That we will see in next video.